Okay, this is another couple of problems that are concerning the shell method. And if you want to just take a moment, maybe pause this video and write this problem down. I got this from your textbook. This is problem number 45 on page 408. So I'll put that on here, page 408, number 45. Okay. And they didn't ask us to use the shell method to solve this. I just chose this, and I'm just going to show you how you could use the shell method, or you could use washers on this one, but we're going to just use the shell method. But you could have used either one, okay? And it doesn't say to specifically use shell. All right, so let's look at part A. The first thing we're going to do is sketch a graph. And I've got y equals x cubed, and I've got y equals 4x, and they only want the part that is in the first quadrant, so I don't have to worry about that other piece. And they're wanting us to spin it about the x-axis for part A, okay? And so, since this is my axis of rotation here, I'm going to draw my representative rectangle anywhere on the piece that is going to be spun. But make sure that your representative rectangle, if you're using the shell method, is parallel to your axis of rotation. So notice that I have drawn my representative rectangle parallel to my axis of rotation. Very important. Then we're going to take our, I'm just going to pick a different color. We're going to take a point on the representative rectangle. It doesn't matter which end it's on. And we want to draw from your axis of rotation to that point is going to be your radius. Because remember, you're spinning it and you're creating these shells. And you're finding, that's what the shell method is. So your radius has to be from your axis of rotation to a point on your representative rectangle. Your representative rectangle is just, one of your shells, okay? And so now when I look at the width of your shell, it's along the y. So it's going to be a y integration. So I know I have y integration. So that means that I need to make sure that both of my functions are solved for x. So y integration, solve for x. So this is going to be x equals the cube root of y. And this one's going to be x equals y over 4. Okay, the other thing I need to know, I know that they intersect at 0, but I need to know this other point of intersection here. I need to know the y value of it, but I'm just going to go ahead and set x cubed equal to 4x, and that I've got x cubed minus 4x equals 0, factor an x out, and x equals 0, x equals 2, x equals negative 2. So that means that this right here is 2. So if I put it into x cubed, it's 8, or if I put it into 4x, it's 8. So I know then that my upper and lower limits of integration using y integration are going to be from 0 to 8. Okay, so now we're ready to find the volume. So we've got the integration from 0 to 8. And remember, this is 2 pi r. Well, for our r, it's just going to be the y value from 0 to 8. So that's just going to be 2 pi y. And then times, and then what is this right here? Well, that's going to be right minus left. So that's going to be the cube root of y minus y over 4 dy. So bring your 2 pi out in front, and I'm going to distribute the y. So this would give me y to the 4/3 minus y squared over 4 dy. And now we're going to integrate. So y to the 4/3 plus 3/3 is y to the 7/3. And then multiplication by the reciprocal, by 3/7, or divide by 7/3, which is multiplication. And then minus, this is going to be y to the 3rd, and then divided by 3. So that means I have divided by 4 times 3. So that gives me division by 12. So I now have 3/7. And remember, this is going to be the cube root of 8, when I put that in there, to the 7th power, minus 8 to the 3rd over 12. And then minus putting a 0 in would just give you 0, so I'm not going to worry about that one because there's a y in both of these terms. And so now, this is going to be 3 times 2 to the 7th over 7 minus 8 to the 3rd over 12. (384 over 7 minus 128 over 3). Oops. I just went straight to the answer here, sorry. This one gave me 5/12 pi over 21 units cubed. Okay, now let's look at part B. Part B is a little different than what we've done up to this point, so I want you to really pay attention, because this can happen. So I'm going to redraw my whole thing again, and remember where what my part is that I'm spinning. This time, we already know that this is 2 and that this is 8, and they want us to spin it about y equals 8. So this is my y equals 8, and this is my axis of rotation. So now, representative rectangle, parallel to your axis of rotation, pick a point on that representative rectangle piece and imagine where is your radius from your axis of rotation to that point. Notice that your radius is going to be a little bit different than just y on this one. That distance here, because if I started from 0 to 8, my radius is going to be 8, and then it's going to go all the way down to 0. So it's going from 8 to 0 instead of 0 to 8 like it was on the other one. On this one up here, your radius started at 0 and it went to 8. So that was okay to use y for your radius. Here, your radius starts at 8. Look at that. See, that first radius would start at 8 and go all the way down to 0. So trying to figure out what this distance is, well, remember that this is the y, the y of your point, which is the y that we're talking about. So for this one, our radius is going to be 8 minus y. And this sometimes happens. You have to draw your radius from your axis of rotation to a point on your representative rectangle to get a visual idea of what that radius will be. And so now, again, the distance along here is delta y, right? So again, that's why my radius was in terms of y, right? Because I knew I was going to have y integration again. So representative rectangle parallel to our axis of rotation, going from 0 to 8, 2 pi times r, which is 8 minus y, times, and then again we're looking for this distance, which is going to be right minus left, so cube root of y minus y over 4 dy. Oh, I forgot to bring my 2 pi out front. That's okay. I'll do it on the next line. So now I'm going to multiply. So this is going to be 8, and I'm going to make this y to the 1/3. And then when I multiply here, I'm going to get minus 2y. When I multiply here, I'm going to get minus y to the 4/3. And when I multiply this last one, I'm going to get positive y squared over 4. Now I'll bring that 2 pi out in front. And I can actually integrate this right now. So y to the 1/3 plus 3/3 is y to the 4/3. And then this is going to be 8 over 1 times 3 over 4 minus y squared minus y to the 4/3 plus 3/3. That's y to the 7/3. And then division by 7/3 is multiplication by 3/7. And then this is going to be y to the 3rd divided by 4 times 3. So divided by 12. So this ends up giving me 6. Divide by 4, I get 1. Divide by 4, I get 2. 2 times 3 is 6. And when I put my 8 in, I'm going to have the cube root of 8 to the 4th power. Minus 8 squared minus 3/7. And then again, cube root of 8, only this time to the 7th power, plus 8 to the 3rd over 12. And then put a 0 in, you get zeros the whole way. So I'm not going to worry about that lower limit. Okay, so on this one, we end up with 6 times 16 minus 64 minus 3/7 times 2 to the 7th plus 8 to the 3rd over 12. And then I put that in my calculator, and it reduced, that whole thing inside reduces to 416 over 21. And so final answer, 832 pi over 21. Okay.